The combined law puts Boyle's law and Charles' law together because sometimes you have more than two things changing. So here's the combined gas law. P1V1 over T1 is equal to P2V2 over T2. The amount of gas is staying the same, but now pressure, volume, and temperature are changing. Again, the temperature needs to be in kelvins. Sample of gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to a temperature of 85 degrees Celsius, what is its final pressure in millimeters of mercury? That's a lot of words and a lot of numbers. So we're going to make a table. So I've got row 1 and row 2. First number I come to, 158 milliliters. That's a volume, so I'm going to label that column V. At a pressure of. So this pressure goes with the volume I just wrote down, so I want to put them on the same line. 735, right in the unit, millimeters of mercury. That's the pressure. And a temperature of 34 degrees Celsius. What do we need to do to that temperature? Convert to Kelvin. Just do it right away. Plus 273. So 34 plus 273. 307. That's the temperature. If the gas is compressed. So here's some words that are saying something's changing. So this is the new volume, 108. So put that in the volume column. And heated to a temperature of 85. That's the temperature. I don't want to put it in the pressure column. I'm going to put over here 85 degrees Celsius. And again, change it to Kelvin. So 85 plus 273, 358. What is the final pressure? So again, I made a table and everything fills in except for one spot. So pressure 2 is what I'm trying to find. So I'm going to use the combined gas law. How would I know to use the combined gas law? Look at the table. I've got volume, pressure, and temperature. They're all changing. I can't just use Boyle's law or Charles' law. I need something that has P, V, and T with 1s and 2s. So P1V1 over T1 equals P2V2 over T2. Reminds me of R2D2, C3PO. My kids always said CP3O. Anyway, we need to rearrange this. It's got a fraction in it, cross multiply. P1V1 T2 equals T1 P2 V2. I took this top P1 V1 times the bottom on the other side. That's how I got this. I take the bottom of this side T1 and multiply by the top on the other side to get rid of those nasty fractions. I want P2 by itself. So I'm going to divide by T1 and I'm going to divide by V2 because I can get them to cancel out that way. If I do this to one side, I have to do the same thing to the other side in order for it to remain equal. P2. And this is a significant reason for the math prerequisite for this course. There is algebra in chemistry. Make sure that you copy it down correctly. And now we're going to put the numbers in. P1, 735 millimeters of mercury times V1, 158 milliliters, times temperature 2, 358 Kelvin, divided by T1, 307. It's almost like a treasure hunt. I need V2, I have to go hunting for it. Here's V2, 108. Be sure to include the units and look at them before you do the math. Here I've got milliliters canceling, so that's nice, and I've got kelvins canceling. If the units did not cancel out correctly, then I need to go change something. I need to convert something. So now I'm going to do the math here. I have two numbers in the denominator. You need to be careful here, okay? So 735 times 158 times 358 divided by, I want to divide by both of these. Personally, I prefer to divide by 307 and divide by 108. A lot of students really want to multiply here. So if you want to multiply now, you need to open parentheses, 307 times 108, close the parentheses, and press equals. So 1253.9, and the unit is millimeters of mercury. And if I look at all those numbers, I've got 3 sig figs. 3 is the decider. It tells me that this 5 remains a 5, but I need to replace this digit here with a 0 so I don't change the magnitude of the number. Or you can use scientific notation, which is better. So what I did, let's see if I can show you without rewriting everything. So I'll show you what I did on the calculator. Oh, actually, leave that one. So in the calculator, 735 times 158 times 358 divided by, open parentheses, 307 times 108, close parentheses, equals. If you get a different number, it's going to be a much bigger number, then you're doing the math wrong. Okay? Question?
Would you still choose 3 sig figs even though Celsius is given in 2?
Yes, I would. Because, yeah, so the temperatures here in Celsius only have 2 significant figures. When we convert them to Kelvin, though, they now have 3 significant figures. Because this is adding. This is to the nearest 1 degree, this is to the nearest 1 degree. Because we're adding a number that is larger, we end up with 3 significant figures. Any other questions? Let's do another problem. A balloon has a volume of 3.7 liters at a pressure of 1.1 atmospheres and a temperature of 30 degrees Celsius. If the balloon is submerged in water to a depth where the pressure is 4.7 atmospheres and the temperature is 15 degrees Celsius, what will its volume be? And the fine print assume that any changes in pressure caused by the skin of the balloon are negligible. So again, make a table. Row 1, row 2. First number, 3.7 liters. That's a volume, so I'm going to label the column. The next number, 1.1 atmospheres. That's pressure, so I'll label the column pressure. 30 degrees Celsius. What do we have to do? Convert to Kelvin. So that's going to be 303 Kelvin. That's the temperature. So volume at pressure and temperature. Those 3 go together. The balloon is submerged, something happened, and now it's saying the pressure will be 4.7 atmospheres. So put that in the pressure column. And the temperature is 15 degrees Celsius. So we convert that to Kelvin, 273 plus 15. It's 288. What will the volume be? That's the question. So V2. I have 3 columns. I need the combined gas law. P1 V1 over T1 equals P2 V2 over T2. So I cross multiply to get rid of the fractions. I want to get V2 by itself. So I'm going to divide by T1 and P2. So those cancel out on that side. So volume 2 equals, I'm going to copy that back down, P1 V1 T2 over P2, well, let's be consistent, T1 P2. Take that 2 or 3 seconds and make sure that you copied it correctly. Now we plug the numbers in. Pressure 1, 1.1 atmospheres. Times volume 1, 3.7 liters. Times temperature 2, 288 Kelvin. Divided by temperature 1, 303 Kelvin. And pressure 2, 4.7 atmospheres. Atmospheres cancel, Kelvins cancel. So in terms of the calculator, I'm going to multiply by the tops, and I'm going to use parentheses here when I multiply the bottom. So 1.1 times 3.7 times 288 divided by parentheses 303 times 4.7, close the parentheses, equals. This time we've got 2 significant figures, 0.8230 liters, 0.82 liters. Any questions? This is learn one method, solve lots and lots of problems. The approach is the same. Pull the numbers out, label them. Find the equation, rearrange it, plug the values in, and solve. Lots of details, but overall the same idea.